All right, first a few thoughts about section 7.5 and beyond. Okay, it's basically going to be kind of a tough section. A lot of people find this to be a pretty tough section, and it's a section about complex fractions. And you basically thought that simple fractions were hard enough. This is complex fractions, and they are more complex. So it's basically going to mark for you a time to make a decision about how you approach the course. Okay? And what I mean by that is you got to think of algebra as a language. It is, in fact, what's called a symbolic language. And so we got to think in terms of how do we approach learning a language. Well, we have a couple approaches that usually people do. One is, let's say you're planning to go on a quick vacation down to Mexico. You might want to memorize a few phrases quickly. Where's the bathroom? Where is the Hotel de la Playa? Where is, or, can I get a hamburger with ketchup only, please? Okay? That kind of eating is my approach to going to a foreign country. So you learn a collection of phrases and hope you understand their responses. So you can memorize a few possible responses and hope that gets you through. Or what you could do is learn some rules and some words and learn how to express your thoughts. And this seems harder, and in a very short run can be. But in the longer run, it's more flexible and more powerful and more easy if you're just learning the language rather than trying to learn a bunch of phrases. And the same thing's going to be true in algebra. The first approach that's like that approach, learn a bunch of phrases, is people want to basically memorize how to do a bunch of different problem types. And so they'll think of different types of problems that'll come up, and they'll memorize them and try to keep them all straight on the final. And that, when you get to quizzes, unfortunately, that works pretty good, because the quizzes only have about 4 or 5 problems. Then when you get to the tests, well, now there's about 25 to 30 different kinds of problems, and then it's already kind of a struggle to keep it all straight. When you get to the final exam, there's about 100 different types of problems you're going to be trying to prepare for, and then it really becomes a problem to keep it all straight. Other option is to learn a few rules and how to apply them. And so that's what I've tended to try to focus you guys on in class. And I remember somebody last semester being blunt enough to tell me what maybe some of you are thinking: you're just trying to make it harder. Why don't we just do it like this? It just says this in the examples in the show. Tell me how to do this. Why don't we just make it like that? Why do you have to, make it so darn hard? Again, what I'm trying to get you guys to do is learn a few rules and apply them. And what's going to happen again is, while it seems like the hard way up to this point, it's going to be more powerful and more easy in the long run. Plus, as an extra added benefit, the idea of taking problems and analyzing them by knowing to apply some rules rather than just memorizing a recipe is the kind of critical thinking skills that employers want, that'll make you more successful in the future, that are the reason why math is required even if you don't plan to work in a quantitative field. Okay? So what does this have to do with 7.5? Why am I bringing this up now? Well, these are problems you're going to see that are real difficult to memorize. Real difficult to memorize, for one thing. You won't instantly see the answer, as happens in some problems, though we've already seen that happen already. What's new today is you may not even see the complete approach. You may not be able to look and say, oh, that fits this pattern. Or we just do this step 1, this step 2, this step 3. You're not going to even necessarily see the complete approach. All you're going to be able to do is know your rules, see if you can change up the expression a little by following the rules, and see if you can make the problem just a little bit easier. Even though the rule you use may not make it easier, it may make it a little harder. And then you'll have to go back to the drawing board and try again. But if it makes it easier, usually what you can do is apply a rule, make it a little easier. Well, then apply another rule, make it even easier still, and go through and through over and over, step by step, making the problem simpler until you're done. So that is the approach that you'll need for this section. But it's also, I'd like you to invite you to make this kind of more your approach for other sections as well, and on to the test, trying to learn that approach of memorizing, remembering a few rules, a few definitions, and applying them rather than trying to just memorize a process and not caring what it all means.
When is our test?
Test, by the way, the next test is scheduled for next Friday. I believe it's next Thursday in this group because this is a Monday through Thursday group. But for the online class in the other section, it's next Friday. Okay? So let's look at one of these problems. We're supposed to do this, and you can see where, oh God, that's just kind of a hairy looking problem. 7/11 plus 3/22 over 9/5 minus 1/10. You gotta take it one step at a time and unpack it. You can't just expect you're gonna get the solution or the right approach the very first time. So let's go through and rewrite this problem. We got 7/11. And I want to make sure the brush size is nice and big. Plus, you go back here, 3/22. Whole thing over 9/5 minus 1/10. So we're going to look at not trying to solve the problem all at once. I'm going to think through. And what I will say is the first thing we want to look at is right here, this division bar. And the division bar has two meanings, right? First of all, obviously it means what?
Divide the sum of 7/11 plus 3/22 by the difference in time.
Yes. So it means dividing, and implicit in your answer then is the other thing it means is grouping. That is, we got to do this first, then we got to do this, and then we divide. So grouping or parentheses is a second meaning of that. And so we can change this problem into 7/11 plus 3/22 divided by 9/5 minus 1/10. Still looks pretty gruesome. Got to admit that. Still looks pretty gruesome, but we've done something. It says, let's just look at it a different way. This is a different way to look at the same problem. And we get that different way by realizing that that symbol means divided by, and it also means to group the things that are on top of it, group the things that are on bottom of it. And so we just took advantage of that and said, let's look at this a different way. Now, parentheses always tell us to do what? What do parentheses always tell us to do? Do the operation inside the parentheses first. So we're going to do this operation here, this plus, and this minus before we do the dividing. So now, in terms of doing that plus, what do we have to do in order to add 7/11 and 3/22? Same denominator. And so how would we get a common denominator? Multiply the 7/11 by what? 2. Not just 2. And I'm going to be picky on this because you probably had the right idea, but it's 2 over 2. See, 2 over 2 is equal to 1. So that's why we get away with doing that. Okay? So now we've multiplied that by 2 over 2. By the way we're going to have to multiply these two, it also happens to be multiplying the first item by 2 over 2. It's going to make these both tenths. So now let's rewrite this. Okay, so I've got now 14 over 22 plus 3 over 22 divided by 18 over 10 minus 1 over 10. And then that's easy. We just add the numerators. 17 over 22 divided by 17 over 10. Okay, so now what can we do to make it simpler? This is now looking a lot like some of the earlier problems. What do we do with that? What do we do when we're dividing? Factoring things seems like a good idea. So I know this 17 is just 1 and 17, so 17 is prime. But 22 becomes 2 times 11. That may or may not be useful for us. And notice I'm starting to write the times instead of divided by. Because what do we like to do with division problems? Multiply by the reciprocal. So it's easy to multiply by the reciprocal. So now we make the numerator 10, or 2 times 5, and the denominator 17. Now we know what's going to happen when we multiply is all the tops are going to be, all these numerator factors are going to be factors of the numerator. All these things are going to be factors of the denominator. It's going to multiply numerator times numerator, denominator times denominator. Well, since that's going to make all these numbers in the same fraction, we know that 17 over 17 is going to be part of this fraction. And we know it just cancels. Factors that are common in the top and bottom cancel. Same with these 2's. These 2's are going to cancel. And then we are left with 5 over 11. And that is our solution, or that is our expression. That's the simplified version of this thing up in the corner. So again, what we did was we first noticed that division bar means divide and group. So we put it up as dividing and grouping. And then we looked at what we can do inside parentheses. Well, we know how to add fractions. We have to be careful, but you all know how to do it. Get the common denominator by multiplying numerator and denominator of each fraction by a strategic choice. And then we actually combine. And then we realize, hey, division is the same thing as multiplying by the reciprocal. So those are the tricks that all come up in these problems. They'll just come up often in maybe a little different order. But there's the tricks we want to learn. Okay? Let's go to the second one here. 9 over 1 minus y over 3 minus 1 over y. I totally messed up the verbal saying that. 9 minus 1 over y. Let's try that again. 9 minus 1 over y divided by, I believe it's 3 minus 1 over y. Yes, it is. 3 minus 1 over y. Now think. How can we change how this looks legally? Change how it looks, but don't change how it is. Change how it looks, but keep it equivalent. 9 over 1, that might be helpful. Okay, I usually don't personally think of this because I'm experienced stuff with it, but if you're uncomfortable with fractions, eventually it might be useful, might be helpful to remember that 9 is just 9 over 1. 3 is just 3 over 1. Now it looks a lot like the last problem we did. So what can you do with it next? How can we rewrite this? I'll do the first thing. So what do you think I'm going to write? Or what do you think I should write after that parenthesis?
Number 1 minus 1y.
9 over 1 minus 1 over y. What should I write next? Divided by, because this symbol means group and divide. 3 over 1 minus 1 over y. So we've grouped and divided, okay? Now we want to get a common denominator so we can do this subtraction in here. What do we have to do?
Multiply the 9 over 1 by y.
By y over y.
It's
It's also going to be, yeah, 3y over y. And 1 over 1, we don't actually have to do that because 1y is what? Y. So now these have the common denominator y. Same thing by just multiplying this first one by y over y. So now what we get is 9y over y minus 1 over y divided by 3y over y minus 1 over y. Okay? So this ends up being 9y minus 1 over y divided by 3y minus 1 over y. Well, what can I do to this next? Change it into a multiplication problem where you're multiplying the first thing, 9y, excuse me. Let's do some erasing here. 9y minus 1 over y times y over 3y minus 1. And we see y is a factor in the numerator, a factor in the denominator. It can go. What about 3 and 9? Can we do some cancellation here? No. Good. Because 3 isn't a factor of this whole thing. 3 is just a factor of the term 3y. It's not a factor of 3y minus 1. You can't take 3 times something and get 3y minus 1. You can't take 3 times something to get 9 minus 1. You could take 3 times something to get 9y, but not the whole factor, 9y minus 1. So we are stuck here at this point, 9y minus 1 over 3y minus 1. Okay. Let me just show you another approach that might actually be easier to remember. And it's just another trick that's in your arsenal here. Take this fraction, because this whole big thing is a fraction, this numerator, this numerator divided by this denominator, right? It's a fraction. So let's take that fraction and see what happens when we multiply by y over y. Well, let's look at the numerator first. 9 over 1 times y is just 9y. Y times negative 1 over y is just what? Negative 1. Y times 1 over y is just y over y, or 1. Throw a negative in front of it, you got 9 minus 1. Same thing here. Y times 1 over y is just negative 1. Y times 3 is 3y. We managed to do that in one step there. But either way is valid. Either way gets you there. It's just good maybe on this problem sometimes to remember that this might. See, this wouldn't have worked on our first problem. But this works here. Figure out that y over y multiplied by this big fraction is going to clear out the denominator. Okay? I'm going to do one more example and set you guys to working for a while.
So that's the answer is 9y minus 1 over 3y minus 1?
I say yes. And here's why I say yes. Because this is what you want to check here. First of all, the only thing that would make it not the answer, not simplified, is if there was a common factor on top and bottom, on the numerator and denominator, that needed to be canceled. But this is already factored. There's nothing we can pull out of these two. We're done factoring up here. We're done factoring up here. So the only factor up here is 9y minus 1. The only factor down here is 3y minus 1. They aren't the same thing. We can't cancel. That's the only thing that would be left, is if there's canceling to be done. Okay? Right. Well, let's look at another example that is similar, but still a little different. I believe that is number 4 is going to fill the bill there. I've got 1 plus 5y in the numerator. Five over y, I believe it was. And 1 minus 25 over y squared. Okay? Now let's, for grins, we've got those first two examples we could follow where we use this long division bar to change this into a group minus or divided by another group. And we could follow through those steps lockstep. But let's see if there's another tool that can get us through here relatively quickly. If we multiply by y, that's going to clear out this denominator. We saw how that works, right? This is going to be 5y over y, and the y's are going to cancel, and then this will just be y. But if we multiply numerator and denominator by y squared over y squared, we're going to clear out this denominator and this one. Get to kill two birds with one stone. So this becomes y squared times 1, plus y squared times 5 over y, which is one of the y's will cancel, and you're left with 5y. And the downstairs becomes y squared minus 25y squared over y squared. The y squareds are going to cancel, and you're left with 25. And now the question comes back, are we done? And what I suggested last time is let's check factors. Is there factoring we can do? Sure there is. Up top, what can we do? Pull a common factor, a monomial factor of y out, and we're left with y plus 5 as the second factor. What can we do downstairs in the denominator? Difference of squares pattern. Yeah, this fits one of those patterns. Y minus 5, y plus 5. So this thing is y squared minus 5 squared. And that fits this pattern a minus b times a plus b. Okay? And that's a pattern that's going to keep coming back even when you maybe don't see quite as much as the difference of difference of cubes. You're going to keep seeing this difference of squares over and over again. Really important to get that recognized, that pattern. But now that we've got it, we notice, oh, there's a y plus 5 and a y plus 5 they go. Fine. What about this y and this y? Can we cancel them? These two y's? No, because y isn't a factor of this term. Y is just a term within it. It's not, this expression down here is not y times something. Because it's not y times something, y is not a factor. Because y is not a factor, it can't be canceled. We are left with y over y minus 5. Well, I'm hoping that helps. What I'd like you guys to do in here, I'm going to move and detach the